Okay, so they want us to find the area and perimeter of the quadrilateral. So we have this quadrilateral in the middle, supposed to find the area and perimeter. So again, the best way, so I'm just going to do area first. The best way is to make a rectangle around the shape. So I'm going to do that. Straight sides, right? Straight sideways, straight up and down. Make a rectangle that goes around the shape. So the area, here's the plan. The area of the quadrilateral will be the area of the whole rectangle. The area of the whole rectangle, and then minus the, what do we have? 3 missing triangles, right? See those 3 missing, number 1, number 2, and number 3, those 3 triangles that are missing area. So I'm going to take the whole rectangle's area, and then I'm going to subtract this triangle, and this triangle. So I take the whole rectangle and I subtract those 3 triangles. The difference will be the quadrilateral in the middle. Is that good? So let's do it. So what's the whole rectangle? Well, the whole rectangle is 1, 2, 3, 4. Remember, we count jumps for distance. So it's 4 by 1, 2, 3, 4. 4 by 4 rectangle. The whole rectangle is 4 by 4. 16. And we can see it. I like to see it. That's what's so valuable, so helpful, especially to younger folks who are learning this stuff for the first time, to give their hands-on experience with geoboards in your classroom, because you can see it. See how there's 4 by 4? There are 16 squares there, aren't there? See where this formula comes from? It's making sense. There's 4 rows of 4. That's why the area of a rectangle formula is just one side times the other. That makes sense, doesn't it? 4 by 4. There's 16 actual squares there. That's why area of carpeting and tile, all kinds of flooring, is square units, because you're talking how many actual squares. All right, and now we need to subtract the missing triangles. Well, let's do them one at a time. So this triangle out here is 1, 2, 3, 4 by 1. 4 by 1. So the base here, the base is 4, the height is 1. So it's going to be, area of a triangle, remember, is a half times base times height. So for triangles, we have the half. So, and then the base and height are 4 times 1. So that's half of 4, 2. So this one, the area of that triangle is 2. Now you can see it physically, right? Let me show it to you. Because look here. You could just do this if you want. You can say, look, there's 4 squares there, and this triangle is exactly half of that, isn't it? See how the diagonal cuts it in half? So of course, that triangle area is going to be half of 4, 2. Yeah, that makes sense. Math should make sense. And geoboards help us to see how this makes sense. Is that good? Half of 4 times 2? I'm sorry, half of 4 times 1. So half of 4. Right? That triangle is occupying exactly half of those 4 squares. It's 2 squares. Okay. Next, let's do the next triangle. So I'm going to say this triangle here, his base, his base is 2, his height is 3. He's 2 by 3, and so that's half. Well, it's half base times height. I'll write the formula again first off. Area of a triangle is always half base times height. So that's half of 2 times 3, half of 6, and half of 6 is 3. So therefore, this is 3 squares, and we can see that because if we were to draw in, whoops, I didn't mean to do that. That pen there. If we draw in the actual shape, we can see, look at that. There's 6 squares there. There's 6 squares, and this triangle cuts it in half exactly. So it's half of 6 squares. It's 3 squares, of course. There's exactly 3 squares in there. And then finally, for the last part of the deal, come on over here. And I'm going to do This triangle. This one is 1, base is 1, and height is 1, 2, 3, 4. 1 by 4. So his base is 1. His height is 4. He's 1 by 4. So coming over here, it's a half, base times height, half of 1 times 4, which is half of 4, which is 2. So there we go. There's our shapes. This is 2. You can physically see it. If you draw this in, there's 4 squares in this triangle. Cuts it in half. Half of 4 squares is 2. So of course, he occupies exactly 2. So now we can find the area of the quad. The area of the quadrilateral will be 16 minus 2 minus 3 minus 2. We have to subtract those 3 triangles that are missing. So what is that? I think it's 9. I think that comes out 9. So the area of that quadrilateral in the middle must be 9. And that works. So if you add all these up, 9, 2, 2, and 3, yeah, 9 and 3 is 12, 13, 14, 15, 16. That's the whole 16. And we know that whole rectangle has 16 squares, 4 by 4. So that makes sense. That quadrilateral in the middle must be using up exactly 9 squares because the 3 missing triangles and what they're using up. Yeah, that's true. That's right. So we got it. Now, second part, we've got to figure out the perimeter, which is a whole nother problem. Really, it's like 2 problems in one. So let's go down and let me recopy this thing and we'll do perimeter, which is a different deal. Perimeter is length, isn't it? It's not area. So let's do that. Put that down here. All right. So now the other part of this question, perimeter. Now, how are we going to find perimeter? Well, perimeter will be the 4 edges added up. 4 edges added, right? This edge, 1, 2, 3, 4. 1, 2, 3, 4. We have to add up those 4 edge lengths to find out the total perimeter of the shape, the quadrilateral. Well, do we know how long this is? No, it's a slanted piece. It's diagonal. When it's diagonal, it's hard to tell because remember, diagonal lengths are not the same as perfectly sideways or vertical. As it says right here, the distance between points vertically and horizontally is 1, but not diagonally. Things go longer diagonally. So how are we going to do that? Well, first off, look at this piece right here. This piece is perfectly sideways. So let's just put, this guy is no mystery. He's 1. That edge right there is 1. We know that edge automatically. Because why? Because he's perfectly sideways. So if you have any edges that are perfectly sideways or perfectly straight up and down, just write those down automatically, no problem. There's 1 jump, right? Distance is jumps between dots. There's 1 jump. That length here, this length from there to there is 1. But to find the other 3 edges, I'm going to have to use the Pythagorean theorem. Here's what I'm going to have to do. To find this length right here, back that up. To find this length right here, I'm going to have to use the Pythagorean theorem. I'm going to have to come in and make a little right triangle right there. Because it's a slanted piece. I can't figure it out. To find that edge, so we'll call this edge number 1. To find edge number 1, find edge, and when I'm going to use Pythagorean theorem. So this side is 1, 2, 3, 4 by 1. So this is 4 by 1. So that's a squared. Remember the Pythagorean theorem? A squared plus b squared is c squared. And this is the c. because it's the side across from the right angle. Remember how we learned the Pythagorean theorem? The side across, so that slanted diagonal side, you can find it using the Pythagorean theorem. So we say 4 squared plus 1 squared is c squared. 16 plus 1 is c squared. So 17, I'll bring it over here. 17 is c squared. So c is the square root of 17. What's that? I'm getting 4. And so we better use about 4 places. 1, 2, 3, 1. 4.1231. So that distance right here is 4.1231. It's a little bit longer than 4. And that makes sense. It looks like it's a little longer than 4, right? If this is 4 right there, this is just a little bit longer than 4, isn't it? Makes sense, 4.1231. That's in 4 places is enough. In the end, they want 100. They only want 2 places. So you want to use a few more throughout the middle of the problem. And in the end, we'll round it back to 2 places. So use 4 places for now. And then in the end, we'll make it 2 places. So there's that edge. That's edge number 1. And now we've got to do also down here, edge number 2 right here. I got to find this edge right here. So to find that edge, I'm going to do this little triangle right here. And I'm going to say, okay, this is 2, right? Count the jumps. 1, 2 jumps, and count the jumps. 1, 2, 3. 2 by 3. And so that's the Pythagorean theorem also. This edge right here, write it sideways for us. Edge number 2. Edge number 2 right there. Edge number 2. So again, a squared plus b squared is c squared. That's how we find any slanted or diagonal length. We have to make a right triangle. It's the c, it's the side across from the right triangle. This is edge number 2. I'm going to find out what c equals here. C equals. So it's going to be what? 2 squared plus 3 squared is c squared. 4 plus 9 is c squared. Let me bring it over here. 13 is c squared. Root it. C is the square root of 13. Hit the buttons on your calculator. Square root of 13. I'm getting c is 3.60555. I used more, whatever, it doesn't matter. Just use a bunch of decimals. 3.60555. So that makes sense. That distance is a little bit longer too. This is 3 right here. This is a little bit longer than 3, like just past 3.5. 3.60555. Finally, we have one more edge, and we'll have this thing. Let's get this edge right here. Oops, this edge right here. Make a right triangle because it's a slanted edge. It didn't look so straight. It's all right. Let me back this up a little bit better. There we go. Okay, this is my right angle here. So this is the side across. This is going to be my edge number 3. It's going to be C equals. This side is, if you count the thing, it's 1, 2, 3, 4 by 1. So this is 4. This is 1. Hey, look right here. We just did a 4 by 1 right here. 4 by 1 right there. It's going to be the same. Edge number 3 is going to be the same as edge number 1. You see, it's just going to be 1 by 4. Here, I'll do it real quick. A squared plus b squared is c squared. It's going to be, you can save some time. Sometimes these guys repeat. So it's going to be 4 squared plus 1 squared is c squared. 16 plus 1 is c squared. See how it's the same? 17 is c squared. C is the root of 17, which we already have right up here. Square root of 17, 4.1231. So this is 4.1231 again. So we have our 3 edges and this side up here, which is 1. All right, so we've got all 4 edges. So the perimeter, let's come on down here and wrap this up. So the perimeter, total, all the edges added up, you just add those 4 edges. We have the 1 at the very top, doesn't matter what order. And then the 4.1231, and then again, 4.1231, and then the last one, the 3, it doesn't matter what order, 3.60555, add those all up. I'm getting, I got 12.85, rounded to 2 places. 12.8517, and you're just supposed to round to 100, so I just cut it right here. The 1 meant I just left it, I don't round it up. 12.85. 12.85 is the total perimeter. So that's how far all the way around the 4 sides of that quadrilateral. 4 sides. I found one of the sides is directly sideways, so that's just 1. The other 3 I found by the Pythagorean theorem. Add them all up, and there we go.